So, dear students, welcome to the manufacturing process course. In this course, I would like to give the important problems and solutions for the competitive examinations like GATE, IAS, etc. So, in that, the welding. So far, I have studied some of the various welding process. In that welding process, what are the types of weldings? That is solid state welding, liquid state welding, solid liquid state welding. I have studied so many welding process. It is also comes under the fabrication process. It is a secondary process. So in this process, you have studied in detail about what is the constructional features and the principle, advantages, limitations, and applications. Apart from that, majority of the students think that the welding is a purely theoretical subject, but in welding also a lot of problems to able to identify and how do you solve the problems in this welding or fabrication process. Let us discuss in detail about this welding process. Let us see what are the terminologies used in welding. So first of all, a student can able to understand the terminology. So because of this terminology, can able to identify which type of problem to may solve. Yes or no? Either it may be a resistance welding problems or arc welding or any gas welding problems or some of the what you call friction welding problems and some of the what you call butt welding problems. So whatever the thing, the first and foremost thing is you should able to understand the terminology used in welding process. As I discussed earlier, the term welding can be defined as it is the process of joining to similar or dissimilar metals by adding filler, without adding filler metal, by application of pressure and without application of pressure and temperature. This is a common technical definition. And in this fabrication process or welding process, some basic important terminology such as a butt joint, how the butt joint can be drawn and how the effective of this butt joint technique can be used in a fabrication process, and what about the penetration and how the reinforcement takes place, like that the number of items or terms should be important, should be able to understand clearly in this video. Okay, so first of all, let us see this is the diagrammatic representation of butt joint in welding. So butt joint means two pieces. Generally, if you take the workpiece 1 and workpiece 2, both will kept parallelly, and you should provide certain distance so that you can able to perform the welding process to join to each material, each workpieces. So that workpieces may be similar material or dissimilar material. Sometimes we should add some filler metal, sometimes without filler also, and only some heat and pressure, that is called some friction welding and forge welding, etc. That all can discussed earlier. Now let us see what are the basic important problematic terminology where you need to identify clearly. And in general, even if you say the resistance welding also, heat generated, H is equal to I square RT. So this is a simple formula where you can able to explain how you can able to determine heat generated, which is the square of current. This I means current square, and R is it is in amperes, and R is the resistance. This is in ohms. T is the time in seconds. Okay, so like that I square RT. So with this relation mainly depends upon the resistance welding. Again, the resistance when we can be divided into spot welding, butt welding, and projection welding, percussion welding, seam welding, etc. It is available. And here let us see what is meant by a weld face. So this you can see the left side, you can in one of the workpiece one, and right side is another workpiece. How we can able to perform the two pieces. This is called workpiece 1 and this is called another workpiece 2. Both elements can able to join together. Here let us see This is a diagrammatic representation. Weld toe E. So weld toe E, and this is called weld face, and the joint penetration exactly in this horizontal line which shows the joint penetration or weld size, and this at the end we will call it as a weld toe. And generally the butt joint is a technique in which two pieces of the material are joined together by placing their ends together without any special shaping. Okay, simply two pieces can parallelly can keep, and you can able to perform this with the help of the filler rod. You can able to perform. And in that, what about this penetration or weld size? It is the depth to which filler material can be penetrated into the base material. So this is called the base material. So how you can uh, fill the like this, it will be available. One workpieces, other workpieces. This base metal can be filled with the help of the filler rod. So that is why whenever by using the filler material which can be penetrated into the base material, so that is that how much penetration, the weld size also plays an important role in this welding process. And what about the reinforcement? The reinforcement is the term where the amount of material which is projected from the base metal, how much amount of from the material, base material, how it able to project that extra material is called the reinforcement. The combination of that base metal and the filler rod, the both will come in together to form a strong joint. Okay, so that is why these are the another important terms like weld face and face reinforcement, the weld toe. So let us see this is the starting point. This is the weld to left side, weld to right side, and root reinforcement. So root is called, this is called how much distance below this work. This is called the root. We will call it as a root, and this is also size. Okay, so weld size, joint penetration. So these are the some of the technical terms where you can able to understand clearly while solving the simple problems where it is used in a competitive examinations. But the student, they can study clearly about the process of welding process in detail. But when they are asking some of the simple problems, suddenly they may have to think which type of problem, which type of formula to be used, how we can able to develop all those things. So for solving all such type of problems, this terminology is one of the most important in a welding process. That is why I'm discussing what is a butt joint and what is meant by penetration and how the reinforcement takes place. Reinforcement, it is the amount of material which is projected from the base material, that is called the reinforcement. Next, coming to this, what is meant by that fillet welding. So this is you can clearly understand after performing welding. So this you can see, this is called the how they can able to use the fillet welding. The term fillet welding refers to it is a process of joining two pieces perpendicular. You can keep one is the base, one is perpendicular together. So in this case, the process of joining two pieces of metal together, one is horizontal, one is vertical. If you draw a line, this is called uh, throat. You can see that it is the how the fillet can be. So any, if you take the workpiece vertical and one is a horizontal, if you join inclined at 45 degrees, that we can say that fillet. So that fillet means the process of joining two pieces, one piece exactly kept horizontal, the other piece vertical, both will to join together by putting a fillet. Okay, so obviously this fillet angle is 45 degrees is each base. Okay, and these welds are commonly referred to as a T joint. T joint, where the two pieces of metal perpendicular to each other. Even not only L joint, even T joint also you can see. This you can able to perform like fillet joint. Okay, so like this inclination will be occur. So L joint or T joint, any type of this can be used to do. Obviously, the fillet welding is widely used. And one interesting thing I would like to share, which are the two pieces of the metal that overlap and are welded at the edges only. So sometimes, how do you perform a fabrication at the edge? And here another important terminology, you can say the what is meant by root and what is throat, and this is called face, toe, and this is called leg. So leg, how much amount of leg the molten metal is filled in the fabrication process, welding process. Let us see in any fillet welding process. So let us see the term toe, this toe at the top and at the bottom. Just you can, it is the junction between workpiece and weld face. It is the junction between the workpiece. This is called workpiece. And the junction where you can perform the welding, that junction, we will call it as a toe. So it is the left toe, it is the right toe. So it is the mainly it is the junction between the workpiece and the weld face. This is called the weld face, how you can perform any two metals. So if you take in a horizontal, how we can perform like this, okay. So in this case, you can able to see. So how we can able to do this welding process. Okay, so all these comes under the fillet welding. In the fillet welding also, majority of the examination they will ask simple questions. What is the leg length? How we can able to determine throat area? Okay, and what is meant by face? Like trigonometric formulas. Okay, so trigonometric formulas. For example, A, B, C. Okay, so where CB square is equal to AB square plus AC square. So right angle theory, okay, Pythagoras theorem, like that you can able to determine so many simple formulas to be used to determine the areas of the different, that throat or face, and what about that leg length and length, width and height. Okay. And another important, the throat. So the term throat can be defined as it is the shortest distance between the root. It is the shortest distance between the root and one more. This is the called shortest distance between the root to that face. Yes or no? So it is the shortest distance between the root and weld face, and it is the weakest section on a fillet. It is also called the weakest section of the fillet, where you can put more pressure, it may chance to break. Okay, and also what is meant by root? This term root is the point of deepest penetration in a fillet. So at this point, this is called root. The root is a point of deepest penetration in a fillet. Okay, so this is called root, starting point. Okay, and this is the leg length, horizontal, vertical leg length, toe, top and bottom. This is the face. Throat is the distance between the root to the weld face. Okay, so this is what a simple technical terminology which is used in welding in order to help to solve these simple problems we'll ask in any competitive examination. So this is what about a general diagrammatic representation, how we can able to understand the term fillet welding. As I discussed now, the fillet welding refers to it is a process of joining two pieces. One is horizontal, the other one is vertical. Both can be joined together. They are perpendicular to each at an angle. Okay, so this is called the fillet. Okay, and coming to this toe. So the term toe at the top and toe at the bottom means it is the junction between the workpiece and the weld face. It is the junction between the workpiece and weld face. And what about the throat? Throat is the shortest distance. It is the shortest distance between the root and weld face. And also at this point only, it is a weakest section on a fillet. It is a very weakest section on the fillet. That is what about the throat. Okay, and what about the root? The point in the root is the point of deepest penetration on a fillet. It is the very deepest penetration, which is also called the what you call root. Okay, so this is about the terminology which is used in welding process. When you are solving the problems, so these terms are very very important. How do you determine the throat area, leg distance, face and toe and to that point, this thing under while solving the problem, so you can able to understand better manner. Okay, so now let us see another important terminology. What about the weld pool and weld bit? This is more interesting. So look at the three-dimensional figure while understanding the how the weld fit after performing the welding process. So where you can see the color indication of the weld bead, it is a series of bead like a some small strip like a snake form you can able to obtain. Okay, so the term weld bead, it is the amount of material which is added into the workpiece in a single pass. So this is what, for example, there are two pieces. Okay, how you can able to, so when it is a front view, so it is the front view in this area, how you can fill in a single pass at a time, how you can fill the uh, filler rod with that welder. That is the amount of material which is added into the workpiece and a single pass, one pass and two passes also will be there parallelly by doing one direction and other directions also. So if this can be drawn in a three-dimensional figure, how you can able to perform, you can see like this, the two metals. Okay, so here this is a single pass at a time, how you can able to perform welding in a straight. Okay, and if multi-pass means you can do the parallelly this side and this side for a long sized plates and sheets and workpieces, etc. And what about the weld pool? So weld pool is the term and it is the amount of liquid metal between the two workpieces before joining. So that is very interesting. The term weld pool can be defined as it is the amount of liquid metal. It is the amount of liquid metal between the two workpieces before joining. So you can see in the right side diagram, the three-dimensional, how can able to clearly understand the 3D diagram for this is the red color is the weld pool. So you can see how the weld pool can be created, and above that metallic vapor, and this is called the weld beam, and this is called the keynote and free surface, and this is called front melting front, and this is called base metal. So the terminology, so whenever the weld performing speed it will go through, and how the different colors red and orange and some black color, where you can able to understand the weld pool is the amount of material which is added to the workpiece in a single pass. So this is the workpiece, you can add above some layer, that layer only that weld pool. The weld pool strength, if it is more thickness will be more strong, and if the weld pool thickness is less means it is somewhat very less strength will be there. So that is why the terminology in a fabrication process and welding process, the weld pool is the one most important technique where you can able to do it. Okay, this is what about the terminology about the welding process, like butt joint, penetration, reinforcement, and some toe and throat, root, and weld pool and weld pit. So with this terminology, we can able to understand how the arc welding works, the basic principle, what different type of power sources, AC or DC or strike polarity or reverse polarity, all these things and all we'll discuss in detail. Let us see the terminology also. Let us see another, before going to discuss that process, let us see another two important terminology where you can able to focus root gap and how the deposition rate will be can be occurred in any fabrication of two metals. Okay, so here you can see the root gap. So the right side line diagram you can show that root gap means this is the root gap. So the two workpieces W1, workpiece 1 and workpiece 2, the two pieces joined together can able to provide some root gap, and with the groove angle inclination, that inclination will be 30 to 40 or 60 degrees. Wherever that angle of groove can be increased, the filling of the molten metal and whatever the filler metal can be filled in that workpieces, that will become both pieces will be jointed very effectively. So that is what about root gap. This is called thickness and groove angle. And if you are not providing the groove angle, what will happen? So suppose if you are not providing groove angle, like this it will be there, and where you can fill the molten weld, we can fill the weld metal. So that is why this, instead of that, you can able to make an inclination, then you can able to fill effectively, so that you can able to perform easily about the weld metal. That two plates or two workpieces can be joined together easily. And another interesting thing is the deposition rate while performing electrode and filler rod and all. When you touch, there is a spark and flame will be came. Due to that, some depositions also, deposition rate, either it may be slow or fast, or depending upon the material and depending upon the combination of the chemicals added into that workpiece and that filler metal and flex coating, etc. So this deposition rate can be defined as it is the amount of material which enter into the workpiece per unit time, that is per kg per hour. How much kg of material can be processed per hour? That is very important. If you provide the filler rod and all, how much amount of that filler rod material can be utilized per hour or per minute or per second, whatever it may be, the deposition rate plays an important role. Depending upon our application, depending upon our usage, and depending upon the materials also, the deposition rate can be discussed clearly as per the our specification. So in the 3D diagram, how the deposition rate occurs, you can see this all coated, the flex coated will come out. So once it has within a fraction of time, it can be very hard, and it is heated, and by solidification time takes place, it is able to get more strength. And after performing the welding, deposited immediately with the help of the filler, that chipping hammer, you can remove the some excess flexes also, so that it will be sound welding and neat welding can be obtained in any type of welding process. This is what about the terminology which is used in welding techniques. Okay, and now let us see the basic concept of arc welding. This is already explained in the previous videos also. Once again, you should recap of the basic concept of arc welding. So I hope, dear students, mainly let us see any arc welding process. Any arc welding process, there will be one electrode will be kept in electrode holder, and there will be workpiece. Okay, there will be works, and how the arc can be created between the work and electrode. And this workpiece will be joined with the cable, and this is called either AC or DC machine. AC or DC machine, or even DCSP or DC RP. That also we'll discuss in detail later. And this holder, this electrode holder and electrode can be kept to one side, and workpiece will be kept joined in the AC or DC, and so that due to that cable we can able to perform some spark and arc can be generated while touching that electrode, and so that the joining can be performed very easily. The two plates or two sheets or two workpieces will kept together, and when you touch the electrode, when you apply the supply of AC DC, the spark can be generated, arc can be generated, so that the joining can be done effectively. Okay, and here it is a very simple process. Everywhere in the villages or any street, they can take one AC or DC generated, and the workpiece cable can be kept in the earth, and positive negative terminals can be done easily. And in this case, when the electrode is the contact of the workpiece, due to the short circuit, arc will be generated. How this arc will be generated? When you touch that electrode in the work, so there will be sudden short circuit can be happen. Due to the short circuit, some arc and spark can be generated. So to continue the arc further, some gap is maintained between the electrode and workpiece. So there is some gap, electrode and workpiece, some gap will be there. That is known as arc length. So this term arc length also very important. Sometimes in the problems also can be able to determine the arc length of the welding process. How much percentage of arc length should be provided, how much arc length can able to got it by performing any fabrication process, etc. So this is what about to concentrate more heat on cathode and anode. The DC arc welding can be used whenever the most important either AC or DC. When you wanted to use DC arc welding and DC supply, obviously the more heat can be generated on the cathode and anode. Whenever the more heat comes direct current, okay. So generally that is why more than 3000 3500 centigrade of the power can be heat can be generated, and whenever you can touch that holder, the arc can be created. So that is why here the two terms are very important. The one is arc length and another one is the cathode or anode, how much heat can be applied for a DC arc welding. Obviously, when the AC means almost some less heat can be put on the anode cathode. That is why with this principle, let us see the how we can able to study some of the more components of DCSP or DCRP or negative or positive, the polarity of the workpiece and electrode. So that also we'll discuss in detail about this so that you can able to understand clearly. Okay. Now let us see the direct current straight polarity. So DCSP. So direct current straight polarity, or we can also call it as DC electrode negative. So electrode negative, we can also call the direct current straight polarity or direct current electrode negative. Direct current electrode negative. So these are the very important terminology when you are using DC supply to the welding process. In that, what type of polarity are you using? What is meant by DCSP? What is meant by DCRP? And DCSP means, which is also called the direct current electrode negative. That means always you can keep electrode should be negative. Obviously, the workpiece will be positive. Yes or no? So whenever you can keep the electrode is negative, the workpiece automatically positive. So where in this such case, DCSP case, what will happen? The more heat will be on the workpiece. So there are a workpiece and the electrode. If you use the electrode can be negative, workpiece will be positive. So whenever by touch the electrode, the more heat will be generated on the workpiece when compared to electrode having a less and workpiece having a more. And it is used for welding very high thickness material, high melting point materials. High thickness, for example, very high thickness like not only it is a very thin only, like this much thick materials or this type of material when wanted to perform a welding, and we can obviously we can use the DCSP or DCEN, electrode negative. That means whenever you can able to do a fabrication for thicker materials and also high melting materials, we can prefer the DCSP. Some competitive examinations also they will ask what is meant by DCSP. In the objective they will give electrode is dash and workpiece is dash. Obviously electrode is negative, workpiece is kept positive. It is a fundamental technical answer for the DCSP or DCEN. And obviously whenever by using the DCSP, that means the electrode is negative, workpiece is positive. Obviously the more heat will be generated at the workpiece and compared to the electrode. And the depth of penetration also is very more. When you wanted to perform, you can see the DCSP This is very depth of penetration will be very more. If you take the distance, A depth of penetration will be more on the DCSP when compared to other DCRP or AC. So with this only DCSP only, the more penetration rate in the diagram you can clearly understand. DCSP means the penetration will be high, and look at this penetration is very low, C, and this is some B. Okay, so when you're thinking about the penetration, more penetration for DCSP and some moderate is an AC and less penetration is DCRP, reverse polarity. So reverse polarity in the sense, simple thing, electrode is positive, workpiece is negative, that is reverse polarity. So whenever the workpiece is negative means there less heat, and electrode is positive means more heat generated at the electrode. Okay, so that is why low penetration can be occur. And weld deposition rate and speed also very less in the DCSP. So here the more heat generated, obviously even melting but high melting point temperature metals can be used so that weld deposition should be very less, very small deposition rate will be occur, and the speed also very less, slowly it can perform, so that some good more deposition of that usages, and the joint also can perform very effectively. Okay, so this is what about the DCSP, direct current straight polarity, or we can also call the direct current electrode negative. So simply in the title issue they can mention once electrode is negative, obviously workpiece is kept positive only. Okay, so whenever the workpiece is kept positive, the more heat generated in the workpiece compared to electrode. And similarly high thickness and high melting materials can be used. Depth also very high. The more depth of penetration will be there in DCSP, and only the thing is deposition rate and speed is very less. Deposition rate, speed will be very less. Just all these points opposite to the DCRP, reverse polarity. Let us see how the reverse polarity will work. So this is what about the direct current reverse polarity or direct current electrode positive. I hope the student can understand clearly. Whenever the electrode is positive, obviously the workpiece is negative. The more heat will be on the electrode when compared to the workpiece. And previously DCSP means electrode is negative, workpiece is positive. The more heat will be on the workpiece only compared to electrode. That is the only difference. But it is also used for welding less thickness. But DCSP, very high thickness or large thickness, more thickness material can be preferred, and high melting point materials also can be used. But where in the case of DCRP or electrode positive, where you can able to perform very low melting point materials and less thickness, obviously very thickness should be very nominal, we can perform this DCRP. And depth of penetration is very less, you can see. For DCRP, very less. See, depth of penetration will be like a sector type, very less depth of penetration. But compared to AC and EC, very less. That other AC and DCSP will be more depth of penetration. So many times they ask this question in competitive examinations also. That is why the student able to understand clearly what type of power can be used, AC or DC. If you are using DC, either it is a straight polarity or reverse polarity. The straight polarity means the workpiece always, the workpiece will be positive and electrode will be negative. But DC, electrode positive, this electrode will be positive and workpiece will be negative, so that the low penetration rate. But AC means either of that. Here only thing is that is energy created in the half cycle. So look at there is no cleaning action occur. So because more penetration not required, only 70% of heat at the work. This workpiece will be 70%. but the remaining 30% is the electrode only. Okay, so that is another thing. And excellent electrode current capacity also good in this DCSP. And similarly, DCRP means strong cleaning action, so very strong, but 30% heat at the work. Okay, 70% heat at the this. Okay, heated that. This is what reverse. Okay, here workpiece is negative and electrode is positive, means more heat will be on the workpiece compared to electrode. Okay, that is DCSP. RP means more heat will be on the electrode when compared to the workpiece. Okay, depth of penetration is very less, and here the deposition rate and welding speed is very high. So that is what you can see, the flow of electrons and all, more deposition rate. Okay, and the speed also very high. For suppose when you perform DCSP, slow process, time taking process. DCRP means fast, and deposition also will be fastly will be occur in this DCRP or electrode positive. This is what about the DCSP or DCRP. Now let us see the what are the basic types of welding machines. What are the different types of welding machines? And in that welding machines, either it may be constant current type or constant voltage type. How we can able to discuss clearly in this diagrammatic manner. So this is what called, first thing is the constant current power source, and the second one is the constant voltage power sources. Constant voltage power sources. How we can able to perform? This is also called the drooping curve. This is also called the drooping curve. Okay. So whenever the current is on x-axis, voltage is on y-axis, the constant current power sources will come like this, and constant voltage power sources like this. Okay. This is the change in voltage, and this is the change in current. But when coming to this constant power means, this delta A is less, delta V is nominal. Okay, but only delta A is less in the constant power, and constant voltage is this is nominal. Only change in current only it will be more. This is the basic difference between a constant current type and constant voltage type. Even for a small changes in arc voltage, look at, even a small change in arc voltage, corresponding changes in current is very small. These are used in a manual or welding techniques. Okay, and constant voltage type means the small changes of the arc voltage, corresponding changes in the current is high. These are used in automatic welding techniques. Okay, so this is what about this the first part of welding, and some of the specification of welding. Open circuit voltage, what is by short circuit voltage. In general, when you are when you are discussing about the open circuit voltage, it is the maximum rated voltage that can be measured across the two terminal voltage, that is generally 80 volts, where the current is 0. So what is meant by short circuit current means, it is the maximum rated current that can be allowed through a welding machine at a rated condition. So that rated condition is very important. Efficiency will be some 80%. Okay, and this is what about the open OC voltage, SC current, open circuit voltage and SC current. Even while solving the problems also, they are asked to determine what is the short circuit current, what is the open circuit voltage. These two terminology very important. So in the next part, I would like to discuss about the how the problems can be solved with these formulas. That is, x by a plus y by b is equal to 1. This is the one formula. How do you perform this open circuit voltage and short circuit current? And this is also I T by I T I S V T by VO, that is equal to 1. And the general thing is voltage, open circuit voltage is equal to A plus BLA. So these simple formulas to be used to perform determining of the open circuit voltage and short circuit. So many times these type of questions they may ask it in the gate examination. Okay, with this in this first part is over. So in the second part I would like to solve the some important problems which is asked in the gate and the competitive examinations. Okay, okay, good luck.
Like, share and subscribe. Hit the bell icon for more updates.